ship-to-ship missile, which ranges to 300 kilometers. There are some sea skimmer missiles, which flies close to the sea surface and at high subsonic speed. These are all having a range of around 100 kilometers, usually 40 to 70 kilometers. Then anti-sea skimmer missiles, which counter these missiles, are a special brand of SAMs, which very short reaction times and altimeter controlled, fly low over the sea. They usually have a range capability about 10 kilometers or less. Just to give a glimpse, what is the SAM, particularly SAM, tactical class of missile around the world, including in India. It's compiled what are the systems available. For example, our own system, ICAAST', which was morning our chief guest also mentioned, it is inducted into all three armed forces. These specifications are like this. Around the length and diameter, it is all available in open literature. You can verify in these parameters. And the LRSM type of system which are imported from Israel, what our nation is using, is having similar type of parameters like 4.5 meter length and 225 millimeter diameter. And the all-up weight is around 285 kg. It's a two-stage solid rocket motor. I will explain what is two-pulse rocket motor. And the other parameters like warhead and range and flight duration, operational altitude, these are all we compiled in the beginning phase of our what we are telling ICAAST' new generation to develop. So these are the parameters we compiled. I thought this may be giving some glimpse for tactical class of missile, what are the parameters. For example, the HQ-12 is in service in China, having 5.6 meter length, 400 millimeter diameter, and having a all-up weight of 900 kg, and it's a solid propulsion. And having warhead weight of 100 kg. The range is up to 50 kilometers, and operational altitude, it is 25 kilometers, 500 meter to 25 kilometer, and the maximum speed is attains at 3.6 Mach. And it uses infrared and active seeker both for terminal guidance. So it is in production and development also completed. So similarly, China, Japan, US, and there are additional missiles like ESSM and Tenkung for China, Arrow Israel, and SM-2 and RIM-6060 USA. So these are the parameters. In fact, I cut down only few, I brought it. So after analyzing these existing details, and also this is only a SAM, and you have to see the aerial target details also. What are the targets currently our neighbors, I mean, who are all threat to us. So what are the type of weapons they are having, suppose in case of any conflict, if they use, how to neutralize the targets. So these are also we studied, and then we chosen configuration so that which will cater for handling these type of aerial targets. So this is how that our project is started. This actually in aerospace, if you see, this is only a small area, but it's a wash. That's why I told in the initial how we are, zero on to this particular weapon system development. Myself and my team is working on that. Even in DRDO itself, there are other kinds of missiles also being developed. So I am only talking about the project which I am leading and what we have done so far. See, this is all taken from, again, open literature only. The current conflict, what is happening in the globe, and what are the type of weapon system used against each country. For example, Israel, they are master actually. They are using variety of weapon system. You might have seen in the newspaper or news, TV news and all. These are the weapon system they are using for unguided missile called dump bomb. And there are bombs, bunker bomb, to penetrate the hardened structure and bunkers with order of 900 kg of warhead. And they are using 155 millimeter artillery shells, and guided munition. There are called JDAM, Joint Direct Attack Munitions, And Iron Dome, this is very famous. I think you people will be familiar about this one. Intercept short-range rockets, basically a SAM. And David Sling intercepts medium to long-range missiles. Arrow systems and THAAD US, that is US made, imported from US. That system also they are using for, this is a type of short-range to intermediate ballistic range missiles. Against, if you see Hamas, they are using very old type of weapon systems like M75 Iranian 333 millimeter long range multiple launch rocket systems, and the laser guided anti-tank missiles, which is Russian made, called Kornet, and suicide drone or loitering munitions called Shahab. So these are the few weapon system only. It is only published in literature. We don't know exactly whether they are having only this much or more. So this, why I am telling this one is, you can see this currently what type of weapon systems are being used in these two type of wars. So in future we should be also ready to attack if any threat comes. Now we will go to the subsystems for a guided missile. Generally, any missile system is made up of several subsystems for both onboard and ground systems. For onboard, for example, missile consists of airframe, propulsion, guidance, control, warhead, and safety arming mechanism, and fuse for terminal phase, and power supply. And for ground system consists of launcher, you have radar and fire control systems, communication systems, and other support vehicle like built-in test vehicles and transport cum loader vehicle. So these together, onboard and ground system, what is called is a particular weapon systems. Weapon system means the entire things is missile as well as ground system takes part. We call it as a weapon system. There are other definition in the user side like Air Force, Army, and Navy. They call it a squadron. Army, they will say call it a squadron. Air Force will call it firing unit. So like that they will call it. For example, one firing unit consists of, our definition is one radar and one command control unit with communication system and 4 launchers. So this is called one firing unit definitions. So like that there will be 5, 6, which they call it as squadrons. So now in this, all the subsystems are important, but I just wanted to mention the warhead, considered the most important system because this is what is going to destroy our target, while other subsystems exist only for the purpose of ensuring in taking the missile near to the target. So that is the definition what is given. Many of the subsystems, for example, control, propulsion, will be in the flying vehicle, which is the missile, while some of the others may be outside. That's what I am telling in the ground systems. Guidance subsystem is one of those. For SAM, launcher, radar, CCU will obviously be totally outside. It is usually not considered as a subsystem of the guided missile, but ground system, and it plays a vital role in working of the complete weapon systems. So this is a typical, wing body tail missile configuration. Some of the parameters, the diameter, how, anyway, you may be studying in your course also. I don't know how many of you are studying missile aerodynamics. They may be teaching you basic aerodynamics and how the parameters generally arrived. For example, diameter of the missile for the latest tactical weapon class is dictated by the seeker. Seeker is in fact, what is seeker means? It's a mini radar mounted on the missile. The radar, which is main radar, is in the ground system, which will surveillance, lock on the target and tracking. But it has a limitation that ground system radar will have a blind zone, because beyond which the ground system radar will not work. So then how to guide the missile towards the target? So that's why this miniaturized radar mounted on the missile, which will take the missile to guide the missile to go near to the target. Even that, the seeker also has a blind range. So further to take it, then the fuse are used, called radio proximity fuse or laser based proximity fuse. And the length of the missile is decided by the propulsion, because what is the range you are going to operate, and what is the thrust forces required for engaging the maneuvering target. And these are all the parameters will decide your length of the configurations. Once the length and diameter is finished, then the actual aerodynamics work will start. Aerodynamics expert will generate the characteristics of the missile, which will in turn given to system people to study the autopilot design and trajectory designs. Now this wing and fin geometry will be based on how much normal force you are supposed to generate. For suppose if a 5G maneuvering target you are going to engage, then as a rule of thumb, the missile should have 3 times capability of generating the lateral acceleration. So how much normal force is required? Based on that, the wing and control surface will be designed, and position will be designed based on the stability and control requirement. The sections are based on the what are the equipments you are going to, suppose avionic equipment, which will be housed in the missile section. Typically, for example, avionic section will have power supply, and you will have relay units, and you will be having this INS navigation unit, and you may be having the data link. So these are the equipments will be housed in avionic section, and warhead section will be housed in that explosive item will be housed, and the propulsion will be there. And the control actuator will be housed depending upon whether it is canard control or tail control, the position will be decided. And the subsystem arrangement are all based on the cable harness. Actually, see, the electronic subsystem, some system may be at the end of the missile, and subsystem may be in the beginning of the missile. So everything will be communicated through proper cable harness. So the cable harness experts will prepare according to the requirement. For example, airframe will take. Airframe is the structure which flies and carry all other hardware and subsystem in the missiles. These are all textbook information only. Due to friction in the air, temperature will be generated, and considerably, especially during supersonic and hypersonic field. Why we are telling that under this environment, the missile should be a fully intact condition. It should not disintegrate, then our mission goes for task. The strength of material comes down with increased temperature. So the material selection our structure designer will choose depending upon the environment condition, aerodynamic loads and aerodynamic heating. So based on this, the material will be chosen. For example, in our case, the one missile which I am having, wing and fin is chosen titanium, and rocket motor is chosen for 15 CDV6 steel, and remaining airframe was chosen aluminum. So combination of multiple material is being used in one particular missile. So these are all you may be knowing that during flight, generally lift and drag will be acting on the airframe. Both these forces depending on the external configuration of the airframe. Airframe should be shaped in so that it minimizes the drag and maximizes the lift while having desired structural strength and rigidity. Rocket motor in most missiles is made up of maraging steel. Of course, now we introduced another steel also and proven also. Nose cone withstand the high temperature and also act as a radome and have to be transparent for radio waves. Because now the latest missiles are using seeker, RF seeker particularly, radio frequency seeker, which requires, you cannot use metallic nose cone. So the nose cone or radome, it should withstand the aerodynamic load as well as it should be transparent electromagnetically for seeker performance. The nose cone made up of ceramic and polyimide composites are being used depending upon the requirement. So the typical arrangement for a typical avionics section. If you see, this is the one of the airframe section, because you cannot make the missile as a single entity. It has to be section wise, and it will be integrated together using number of joints and nut and bolts. This is the 3D model, shows here how the avionics equipments are arranged in a particular section. Here the important to be noticed is the inertial navigation system, what is mounted in this one. There is one criticality is there. You have to choose a place where the structural amplification will not affect the performance of the inertial navigation system. So in the basic teaching also, they will be pointing out this requirement for any structural engineer who designs the airframe should take care, particularly for the system like inertial navigation system where you are going to mount. It should be strong enough, and the external vibration or disturbance should not pass to this system because it's very sensitive. So this should be isolated. There are some cases they use isolator between the airframe to the systems. Otherwise, it will be rugged so that the disturbance will not affect the performance of this inertial navigation systems. So here, in the initial phase, what we have done, we have just made a cylinder which having 2.5 mm thickness and simply mounted. So when we do sectional vibration, we found that the amplification of the external vibration on this particular unit was beyond acceptable limit. So how to overcome this problem? Then our designer come out that one inbuilt bulkhead will be introduced here, so that the structural rigidity will be more in this region, where this unit will be mounted both in the front bulkhead as well as in the rear bulkhead. So after that, when we do vibration test, then the vibration amplification came down within the acceptable limit. So these are all things when you start developing a real weapon system, step by step you will understand and how to implement and overcome this type of problems. And you can see that there are 3 power supplies are assembled in this one sub power supply, this one power supply, this one is 3 power supplies arranged in such a way that, because each is having different size depending upon the power supply requirement in the entire flight durations. For example, your control system will be consuming more power in terms of current and voltage. That's why that battery size become high. And this is for avionics and this is for seeker. You cannot combine the power supply also in a single. You may ask why 3 different power supply, why not 1? You cannot combine the power supply because the subsystems are designed for a particular current and voltage. So it should be supplied in a controlled manner. If it is a single power supply having more current and voltage, it may damage the other subsystem which is required less current and voltage. So that is why this has been split into 3 depending upon the requirement. Our power supply designer will design according to the requirement. And this also is mounted in this fashion mainly to reduce the structural external disturbance amplification on the airframe. So, as a power supply, it will not be affected much. The functionality of the power supply will not be affected much due to external vibration. However, you are mounting this one on the airframe using screws. So those screws should not be loosened in the flight, and if it is loosened, that connectivity may disconnect and mission failure may happen. So these are the fine things one has to take care. And this one is the relay unit, which in fact whatever command comes from the onboard computer will be passed on to the particular subsystem through this relay systems. See, after initiation of the section, generally the vibration test will be conducted on a shaker table, simulating a random vibration, and based on our experience, we derived some level. What is the level to be given as an input for this section? And under this vibration condition, we will be checking the health of all the subsystems and some functionality also. So everything is meeting, then this system is declared is suitable for mission. And subsequently, load test will be done. This is on the vibration test, and on the airframe, load test to be done, because as I mentioned in the beginning, when the missile flies on the air, aerodynamic load will be on the airframe. So under any condition, the structure should not disintegrate. So to prove that, we'll be, whatever predicted load, some X is there, we'll do up to 1.25 times of X load, so that the structure is intact under the load, proof load, up to proof load conditions. So this is a typical test setup. For example, I am telling this avionics section, it is mounted. It is mounted in this fashion. So we know what is the load distribution on the complete vehicle, and take particular section, what is the load, axial load and bending moment. That will be simulated through multiple type of actuators, the axial force as well as bending moment, and it will be applied up to that proof load. Then we'll physical verification. After the load test, this section will be sent for die penetration test or suitable NDT to check any internal cracks happen or not, and based on the clearance only, this section will be approved for subsequent integration with other missile sections. Now come to the propulsion. I was mentioning about the two pulse. You might be heard earlier 2-stage or 3-stage propulsion system. Here I am talking about, there is no separation actually. It's a pulse motor. For example, this is we call it as pulse 1. This is pulse 2. The pulse 1 will be fired in the beginning for a particular duration, like 10 to 12 seconds. Then the entire missile will be coasting with the energy gained during the power on mode. Then the second pulse will be fired depending upon the target locations. For example, the target coming around 25 kilometers at particular 6 kilometer altitude, then the second pulse will be issued, the time to go around 5 seconds or 4 seconds. Then the onboard computer will decide all these things, because it is having complete information about the target. So it knows that where to ignite the second pulse, so that once the second pulse ignited, the missile will go very near to the target, and then the computer will issue an explosion command to the warhead. So that's the purpose of this. In fact, after LRSAM and MRSAM, which are imported from Israel, this is the first missile in DRDO. We are having a 2-pulse rocket motor, and it is proven beyond doubt. So these are all the textbook information only. So only thing is, before using the motor for flight, it shall be thoroughly tested on the ground. So what we generally do, after making the casing, rocket motor casing, and after insulation, then propellant will be loaded on this rocket motor. After this is a solid propellant. After propellant loading, it will be cured and it will undergo NDT after curing to verify the rocket motor intactness, whether any crack is formed or not. Then once every batch of motor, suppose for example 6 motors in a batch, one motor will be picked up randomly by the quality agency, and it will be subjected to ground test. So the ground test performance will be compared with the predicted performance. Once satisfied only, then this motor will be allowed to integrate with the missile systems. So very stringent QA and dimension tolerance are required to achieve expected performance of the motor. This I am talking about only propulsion. It consists of so many other things. For example, small explosive, like in the front section, the safe and arming mechanisms are there, and TBI, that is through bulkhead igniter, is there, which will ignite the pulse 1 motor as well as pulse 2 motor, and there are detonators are there, which should issue the detonator command for firing the rocket motors. These all will be assembled in the head end of the motor, having a connectivity for both pulse 1 and pulse 2 motor. And these and all, I think you may be aware that this is a fin O cylinder configuration of propulsion, 8 fin. these fins are selected. In general, the fins are selected based on the requirement. Suppose it is a SAM system, surface to air. The moment firing command given, the missile should clear the launch area. Otherwise, what will happen if it is falls on the launch area itself? It may harm the scientist or manual working around the system, and it may damage the ground subsequent systems. So the missile should clear the launch area as much as possible. So that's why in this case, we have chosen 8-fin O cylinder configuration, which gives initially very high thrust for very short durations. So immediately it will clear within 500 or 1000 milliseconds. It will clear the launch area. So these designs are based on the requirement. For example, vertical launch missile and all will be very slowly, it will take off and clear the launcher after a few minutes sometimes, or few more seconds. Those things, they will choose the configuration, propulsion configuration depending upon the requirement. Now come to the one of the main important subsystems, guidance system. Is the brain of the guided missile. It works out the course that missile should steer from instant to instant based on a predetermined law to achieve interception of the target. The kinematics is the study of different trajectory and the lateral acceleration required from a missile to remain on these trajectories. Because you know the target position which radar gives, and which will be transferred from ground to missile through data link. And once the missile onboard computer receives the things, then this guidance will work according to the guidance law chosen. The trajectory of missile will depend on the guidance law chosen. Some trajectory will call for high rate turn. For example, this SAM is required that much rate turn, while other will be move benevolent. Guidance system works out any deviation of the missile from the selected trajectory and acts through the control system to bring the missile back on the selected trajectory. There is a separate, one big division is there in DRDO to look after these type of activities. Now there's control systems. The control system in turn fulfills this demand, thus ensuring that the missile flies at desired trajectory. Guidance and controls are twins, and it's often difficult to demarcate the boundary between them. Preferred guidance method depends on the role of missile, like air to air or surface to air, ship to ship, etc. Also, different missile in the same role may adopt different methods of guidance. Each one having its own advantage and disadvantage. This choice of guidance will be selected depending upon the requirement. Often the expertise and experience of the manufacturer with the different methods of guidance decides the choice. Combination of different guidance methods also is common in missile systems. Now this I was mentioning in the beginning that seeker, I just want to give a brief of each subsystems. This is I was mentioning, this is the miniaturized radar which is mounted on the onboard. This active home guidance system, the source of the signal that irradiates the target is installed on the onboard the missile. Signals are reflected from the target and are received by the onboard direction finder and are used to measure the mismatch between the missile velocity vector and the velocity direct from phase center to the seeker's antenna to the target. So based on this, correction will be given to steer the missile towards the target. Active homing head, which carries out irradiation of the target designated for destruction with a radar signal, reception of the signal reflected from the target, and it is processing and measurement of misalignment, pointing error in two perpendicular planes. And the onboard computer, which participates in the processing of the received radar signals, that calculates according to the data received from the homing head, particularly from the seeker antenna. The missile radar or command will be issued to steer the missile. Autopilot, which control the missile, controls surface according to the commands received from the OBC. It also controls other parameters of the missile flight. So the nose cone, what I was telling, particularly for this particular missile, is made out of fused silica, which is a brittle material. So handling is so carefully to be handled. The material is chosen mainly because not from the point of strength, it is from the point of transparent for electromagnetic requirement. Because radar is sending signal and receiving the signals, so this should be electromagnetically transparent. Next, come to the one of the other important subsystem, actuator. Actually, there are many types of actuators you might be studying or might already studied. Linear type of actuator and rotary type of actuator. So in this missile, we are using a rotary actuator. In fact, rotary also there are different types. Each actuator will have independent controller and it will be separate. Whereas in this case, this is a typical actuator, I can say the first of its kind, developed in DRDO, having 4 different actuator positioned at 90° each other and with a common controller. The controller is single, which will control all 4 actuators. And it is assembled in such a way that this will be mounted at the end of the missile where these control surfaces are mounted. This is a tail control missile. That's why this actuator also assembled at the end of the missiles. The interface what is given here, the slot and 2 holes, will have a similar mating interface on the control surface, which will be assembled and fastened. And when the command is given, this rotary, this actuator shaft to the BLDC motor, there are chain of gear systems are there. The rotary motion of BLDC motor rotation will be transferred to the control surface through 4 or 5 stages of gear sessions. That gear ratios are chosen depending upon the requirement. This rotary electromechanical actuator consists of 4-stage gear sessions with the BLDC motor and quad channel control. Aerodynamic control is achieved by the deflection of control surface and thereby getting side forces. When the control surface is deflected, a moment acts about CG of the vehicle that provides the lateral force. You all know that. The deflection of the control surface is achieved by actuation of this system. In the actuation system, 4 independent controlled rotary actuators use 90° each other for 4 control surfaces. And rotary motion of the electromechanical actuator is transferred to the control surface through a gear train mechanism. Gears are housed inside the block, which is not visible here. As per the requirement of the fin movement, corresponding commands are given to the actuators. Rotary motion of the actuator is converted into angular deflection with the help of gear ratio. So this actuator, it may looks to be simple what I am telling, but the struggle what we have faced in this development is really enormous. Initially, actually, when we developed this one unit, proto unit, when we want to qualify, what are the method of qualification? We can apply some static load. Am I audible? Okay. The one way is to apply a load on the control surface, static load, and see the deflection. Under the condition, you can give a deflection and check. But that will not reflect your true picture of what is happening in air when the missile flies. So what we done, we have taken one channel and along with the actuator, along with the external surface, we have tested this one in our supersonic wind tunnel. The in charge for that wind tunnel test is Mr. Shanmugam is sitting here. He knows about the how much amount of work gone into this subsystem qualification. So then typical flight profile will be given as a command to this actuator through onboard computer mounted beside the wind tunnel, and under this deflection, flight command deflection and specific dynamic pressure conditions, for example 5 or 4 or 6 atmosphere, under this condition the actuator has to execute the flight command what we are given. At the same time, it should be intact without any structural failure or structural integrity in that conditions. So n number of tests has been done. Finally, this system has, initially we have worked on the linear actuator. We failed many times. Either actuator used to fail or the control surface used to fail. So for this type of quick reaction missiles, rotary actuators were very suitable. That's what we observed from the internal test. And now, once that was qualified in the ground in this manner, we have done so far 9 flight tests, and there was no issue in all the 9 flight tests. Power supply, which I was referring to that picture. Generally, we use for, this is a single shot device. We will not be using the secondary battery. Secondary battery means you are aware now, like car batteries and all, which will be recharged. But whereas in this case, we use the thermal battery, which is once fired, then that's all. It will be no use. It will be thrown. So the entire missile itself is a single shot device. So the thermal batteries are being used for this purpose. Some of the details of the batteries are given here, which will not be defined. It's all textbook. It's given actually. And you see this typical one of the battery has been tested under the full load condition. You can see that in general our mission, it may be 90-second or 120-second flight duration, but we used to test up to 5 minutes. So this is how the system is qualified. For 1.5 minutes flight test, we have to do almost 5 to 6 minutes. This battery should work. So with this type of margin, so we can have more confidence that system will work in flight. Now come to the one more subsystem, is a data link. Generally, see, once the missile takes off from the launcher, how to send the target information to the missile, how the missile will come to know where is the target. So the radar will search and lock onto a particular target, enemy targets. Continuously it will be giving information about the position of the target, but how to send it? There is a method like bidirectional data link. There is one data link on the ground station, which will receive the data, target data from the radar, and it will pass it on to the missile. There is in missile, there is one more unit which is receiving the data, and after receiving it will pass on to the onboard computer. Then onboard computer will do necessary function after receiving the correct data. So this is another subsystem which we have developed and used in our missiles. This is a typical trajectory. Just you can see for a range of 30 kilometer, our algorithm designer used to design this trajectory, and the missile will take off from ground, and suppose if the target comes at an altitude of, this is the incoming target, at an altitude of 6 kilometer, then interception will happen at 30 kilometers soon. So based on this, the positioning of the weapon system will be chosen by the user. Suppose if the missile is having 30 kilometers, then they will choose particular location where if they launch from that location, the target can be engaged at 30 kilometer range itself. So we need not to wait to target come to our safeguard place and all. The corresponding altitude versus time and the velocity Mach number. This is what I was telling. See, first, once the first pulse is fired, the missile will accelerate up to this Mach number. Once this first pulse's duration is over, the missile will be coasting for the entire duration. Then depending upon the target location and engagement requirement, the second pulse will be fired. You can see this is where second pulse fired, and this will be an interception point. So this is only a typical trajectory, and you can choose depending upon target location, the computer will choose and execute the pulse operation. Now come to some information about the ground system, which I was mentioning in the beginning. Radar. It plays a vital role in securing the nation interest at all times, be it war time, during which these systems are the eyes and ears for our Army, Navy, Air Force. During peacetime, these systems from the first line of threat alert for our forces. Radar was thrust with multiple responsibility, such as weapon location, fire control, threat alert. And this multifunction radar starts the surveillance function, searching the entire 360-degree azimuth, as well as 60 to 70 degree from 0 to 70 degree in the elevation plane. Once a target is detected, it is verified before target track is initiated. And track is uploaded using future search returns or from dedicated track wells. These tracks are presented on the operator console at CCU for firing the missiles. So this is the main role of radar. You can see this typical picture of radar mounted on an Indian trailer-based system. Now this is a specialty of this radar is it's a 4-wall radar and it is electronically scanned. There is no rotating part. If you see any other radar, like even our airport also, if you see, the radar will be rotating like this. So the update rate for this mechanical rotation rates are much higher. I mean, uptime for one revolution, it may take a few seconds. Here, the update rates is order of 10 hertz. So that much fast, because of electronically scanned, there is no mechanical rotation involved in this one. This is the first of its kind in this for ICAAST new generation has been developed by LRD Bangalore. You can see this 1, 2, 3 and 4. The 4 walls are mounted in each 90 degree. This will cover almost, each wall will cover 110 degree as an included angle, so that there will be some overlap from one wall to other wall. When it is when it electronically screened, screened position, the target should not at any time should not be dropped. Otherwise, missile will go blind. So the target position to be given to the missile continuously. So that is possible only when this type of information is available. And morning our chief guest also was mentioning that radar cross-section area for latest weapon systems and all. So now this radar is capable of, searching, tracking of a target which is having a 2 meter square as well as 0.1 meter square also. And the range is, depending upon the range, it will be searched and tracked. And it has a 360-degree coverage. And these are the facilities are available in that radar. And the communication from this ground system to one system to other systems are, many are there. Radio is there. Radio is also LHF, low frequency and ultra high frequency, and cable also, fiber optic cables also is used. And there is one more electro-optic tracking system. Generally, this system is used whenever any anti-radiation missile comes towards our systems, because the ARM missile, anti-radiation missile, always aim for destroying the ground system, mainly radar. Radar is one of the costliest weapon system in this total things. If a weapon system costing 1,000 crore, the radar itself will be 500 crores. So this is to be safeguarded very carefully from the enemy's attack. So what we'll do, suppose if any ARM comes, if radar tells us, immediately the radar will be switched off and this electro-optic tracking system will be switched on. This has got 3 types of sensors, a laser-based, day camera, all those things, which is having some 45 kilometer range. It will detect and track. So this type of subsystem will be used whenever any anti-radiation missile comes towards our territory. Other one is launcher. This is another important missile, which is the function of the launcher is to transport the missile, emplacement slewing, tracking, launching of cannonized missile in a hot launch mode. So we have developed 2 launcher for this case, which is having the capability of launching of missile maybe from an inclined stationary position or on the move from elevation 10 degree to 80 degree, any angle we can fire, and it 360 degree azimuth, anywhere you can fire. The missile launch system has sometimes been configured on mounted on a trailer platform or high mobility vehicle, depending upon the requirement. Suppose if the system is going to be used in Kashmir or Ladakh, it's a hilly terrain, so it should be mounted on a high mobility vehicle rather than trailer based vehicle. the trailer-based vehicle will be used in a flat surface wherever in our country. The MLS system should be capable of operating in semi-paved and unpapered surface also, because the moment you are going for some place where if you want to launch the system, you cannot expect 100% prepared land. So the system should be capable of even unprepared surface also. It should be positioned and immediately should be in a position to fire. MLS provides capability of launching canisterized missile in single as well as ripple mode. That's all depending upon the requirement. Because what do you mean by ripple mode? You know, suppose if your target, radar says that's very, very dangerous, then we should not worry about firing, keeping quiet after firing one missile. So you have to make sure that more than 100% that the target is destroyed. So for that, multiple missiles will be fired against the same target, single target. So that's called ripple firing. The launcher shall be capable of providing means adequate protection for the missiles, canisterized missile, while in loaded condition on the launcher, beside enabling safe and reliable transportation of the CMs over long distance across the country. So this is a typical picture of a launcher what we have developed for currently. Consists of many subsystems. This is the canisterized missile. 6 canisterized missile will be there, and it will be, the elevation will be achieved through a particular set of actuator, and it is capable of rotating all 360-degree. It consists of its own power station, DG set, and the antennas are mounted here. And this is the prime mover. Actually, during launch, this vehicle will be detached from the launcher. This will go away, and only launcher will be positioned. And other necessary communication equipment, outrigger, all these things are positioned here. Thank you. This is one of the latest launcher developed with all the state-of-the-art technology inbuilt. And it has been used many times for our testing of the missile. Next comes the command and control unit, where this is the only in the complete weapon system. This is the only place people will be sitting here. That is, the operator will be operating the missile. Neither on the launcher nor on the radar, nobody will be there. It will be positioned almost, radar will be positioned 10 kilometers away from this system, and launcher will be positioned away almost 2.5 kilometers. So the person who is sitting on the command and control unit only will see both the systems and initiate the firing of the missiles. It's an automated command control center. It performs command control function for weapon system. It receives and processes the target data from the radar or from the neighboring firing units, or there is a ICAAST, which is Air Force is having a sensor. That is, you have to receive it. Suppose in case our radar is not working, then you can take the information from this ICAAST and process the data and fire the missile against target also. That is another provision. And CCU shall perform target classification. Actually, suppose that some target comes. First of all, we should know whether it is a friendly target or enemy target. For that, there is one IFF system is there, identification of friend or foe. So that will tell us whether it is our own aircraft or our own missile is coming. So that if that is the case, we should not fire. That identification to be done before firing the missile. And CCU shall provide integrated air defense for defended area using missile as its primary weapon. That is known. It shall receive input from radar or from EOTS if it is ARM type of target for air targets, and using a missile launcher to neutralize the hostile targets. The CCU of one firing unit should be capable of interacting with other firing units also, I mentioned in the beginning. In case one CCU in one of the missile fails, then immediately the other CCU of other firing units should take over and control all the 4 launcher in addition to other 4 launcher. So that is the way this design has been done. And CCU shall be capable of working under different control for air defense. So known. So this is a typical picture of command control unit. where this is the shelter, it's a EMI-EMC protected shelter where the operator will be sitting inside, receive the data from radar and process it, and through the data link mounted here, this ground system data link will receive the data and send it to missile through RF, and missile will receive and given to OBC for further processing. So this has a satellite communication also mounted on the front to interact with the integrated air command control system also. Here also this prime mover will be detachable in this particular system. Then during firing, this system will be mounted on the outrigger. This has got outrigger facility also. And communication. As I mentioned that the three major ground system should be in a position to communicate each other. Then only it can coordinate for getting the data from radar and processing in CCU and giving to ground data link, and ground data link in turn to pass on the missile which is flying on the air, and in flight missile should receive the data properly and given to OBC. So these are the function will be done on the missile communication, and even ground system to system also to be communicated. There are many systems like fiber optic link is there, and short range communication radio system, that's what I mentioned here, and voice communication switching system also is used. 4 or 5 types of communication. In case one communication fails, then there should be a redundancy. In this case, 3 are there. 2 radio communication and 1 fiber link. So this is a type of network. You can see how this, what I mentioned that this is one firing unit actually. This box is one firing unit. Like this, there will be 6 firing units if there 1, 2, 3, 4, 5 like this is, and it will have Air Force network also. So suppose in case one CCU fails here, and this CCU should take care of 4 launcher of its own and also this 4 launcher of other firing units. So the system is designed like this, the ICAAST new generation, and I can say, in fact, this is ICAAST is already inducted. That communication is totally different. That firing units. This is latest one with all updated technologies. I just wanted to mention something for the students are there. See, actually in one of the flight, when we went to Balasur for integration things, our people brought the wing and control surfaces in a separate box, missile in a separate box. But the person who was assembled, arranging that wing and fin has brought one earlier batch unit also. So after going to Balasur only, when you put this one, it was not matching. So tomorrow morning you have to fire, and today evening we are finding this issue. How to, one is that type of issue. Other one is, suppose if the system is not matching when you are doing integration, on the site, launch site, you cannot do any filing activity because it's made out of titanium. Filing of titanium material, you all know that is next to impossible, and it will give a rough surface after filing and all. So in the beginning, the tolerance specification, I think now you may be studying that engineering drawing, I hope, in your curriculum. So it's very, very important that you should understand the basic of tolerancing and the projection for making any real hardware. So we, in one of the other missile systems, that one umbilical connector was not properly mated. It was, the moment firing command given, it failed immediately on the next one. So because of this mismatch of tolerances. So I just thought that the engineering drawings is how important. So once you start working on the real hardware system, these importance will be known. When we studied here, people used to, generally our tendency is to take light. So this is what is so great in this one. But when you working on the real hardware, this such a small issue you may feel now, it is a critical in the mission actually. Other practices now, suppose if any system we develop, at present, even if you are doing a project, for example, your BTech thesis or something, the complete, for doing a project, your bill of material should be known. Each one system should be given as a name with a number, if you practice at this stage, it may be very useful when you go for facing the real life problems. So this is another one area we are now struggling. I mean, now our lab is taking very serious action to formulate these things. The people who are all working in the labs and handling the real type missile and weapon system hardware, so they will come to know this, what is the importance of these ones. I just thought that I can share this information with you. Third one is that integration procedure. Whatever work you do, there should be a set of commands should be prepared, and we may think that I know everything is in my mind, I can do it, but you are prone to miss some of the activities. So it is better to make a document, the integration procedure, so that one person has done the job and third person should be verify each and every step, everything is covered or not. See, I'll tell you one example. One warhead was integrated with the expert came from ARD, but there is one small pellet is there which will initiate the warhead initiation, but they forgot to put that pellet. Without putting the pellet, they integrated. When they given a command, warhead is not destroyed, not initiated. So that is it's a lapse of your checklist. So this also, based on our experience, now we are for each and every activity, if you work out a procedure and if you strictly follow, then you may not, your failure rate will be minimized. And after that, like what we follow, that there is a project representative will be there, then quality representative will be there, then supervisor. All three people has to sign it and give. Then only the other flight readiness committee will say, okay, you go ahead like that. So these are all the stringent rules followed. This why I am bringing out is that if you follow the discipline now itself, even in your project time, it will definitely will help. You need not to come and learn at the time of when you are going to handle the real life systems. Then this different type of, when we are making a missile, there are so many levels of test. First entire missile will be spread over a bench, tabletop, and check the health check, and complete launch system will do it. And after clearing the bench level test, then you put all the airframe, all the section in the airframe. And before integrating with the section to section, once again you check. Then missile will be electronically connected but mechanically disconnected. That is one stage. And check the complete testing procedure. Then you connect everything both electronically and mechanically. Then you do the test. Then if it is a canisterized missile, you put it in the canisterized missile, canisterized. Then you check the missile, again testing. With all this test up, then only we'll go for a trial. This all mainly to see this, that's what I'm telling you. If you miss some steps in particular stage, at least it will reflect in the other stage. So at least people will alert, this function is not working, so we have to dig out and check. So that we need not to face a failure in the mission. You can see the failure in the section level test or whatever things. So that is not a problem. We will not be losing our time and money. But we should not afford to fail in the mission. So for that, the stringent checks are required. In fact, we used to take photograph and videograph also, so that the next mission integration, the person who is doing the job, he can see the photographs and mission. I'll tell you one thing, that one unit, data link antenna unit having 4 screws, equal length. So it can be assembled in this variant and also, or 180 degree rotate also, it is possible to assemble mechanically. Whereas the connector, electrical connector, if it rotates to 180 degree, then your cable length, it will not go and mate. This after integration, people used to, sometimes they will see. So what the design, if you say, if you are assembling in particular direction, it should be assembled. If by mistake, if you rotate by 180 degree or 90 degree, it should not match. So these type of feature, if you bring in the design, so mistakes can be minimized. So these are the lessons learned in our things, and we are incorporating in the design. This is a typical phase check. Missile is electrically connected, but mechanically not connected. This is one type of testing just shown schematically. You can see. So this is a missile. connected with the simulator, and this is a data link, a power supply, and a ground data link. This ground data link transfer the data to missile through RF, and in missile they will return get it RF. This is TX means transisting data, this receiving data. And in the ground we use a commercial power supply. So these are the power supply for 3 thermal batteries are used, simulating the internal and external. Because actual thermal battery you cannot use in the bench level test. It's a one-shot device. So to carry out the ground test, we will be using similar power supply on ground. This is what internal power supply, simulating internal power supply and the external power supply. Then flight test. I just want to show one video. Can you please switch off this one? This is only for our people who will assembled here, not for other